Thank you all very much for joining us today. We are, as usual, incredibly happy to see you all with us here today. My name is Tabunshchyk. I am one of the directors of Women Who Code London community. And as usual, I would like to start with a quick introduction of what Women Who Code is. Please follow us on social media, tag us, message us. We are always happy to hear back from you. Women Who Code does not restrict attendance participation in events by any criteria. The only thing we ask of our participants is to follow our code of conduct. The full version is available at womenwhocode.com/code of conduct. But long story short, is be nice to each other. Women Who Code's mission is to inspire women to excel in technology careers. The global community is spread across 20 countries and has more than 230,000 members worldwide. I always tell about this amazing, in my opinion, initiative that Women Who Code offers. It's Upload Her. You can submit it on the global website for yourself or your friend or colleague, sharing your successes. It's always super inspiring to read how we all succeed together. How to get involved with your local community. This community is run completely by volunteers. So we always need help. First of all, we need leads who could help us to supervise particular directions, help us to organize events, workshops, mentorship in particular areas. Commitment, the official guidance says one event per month, but it's completely up to you. We're always happy to receive any help you can offer. We need evangelists who could help us to promote our brand in social media. Project managers who can supervise from administrative point of view particular events. Episodic volunteers who could help us with design, but we go back to offline events with photography, videography, logistics, welcoming our attendees, like registration desk, and so on. Dear women, we need you. Thank you all very much. And we promised for this series of events to issue certificates if you complete at least 75%, if I remember correctly, please correct me, Galyna, if I'm wrong, 75% of the exercises per workshop. So Galyna is going to grade them, all of them, within the next few days, and then I will be contacting you by email if your name on Google Classroom is looks like a nickname. I will be contacting you to ask what to put on the certificate in case you would like to change something. Yeah, so we will be in touch with you shortly. As usual, if you have any questions during this workshop, please ask them either in the chat, and we are going to check it from time to time, or you can use Zoom functionality to raise your hand, and then you could unmute yourself and ask your question verbally. Yeah, I think this is all that I wanted to share with you before we go to our main part. And as usual, if I may ask you to turn your webcams on, so I could take a screenshot of our participants today. I really like when we have offline events, we always make like a family photo with everyone. It's super sweet and something to remember. But because we are meeting here online, we are going to deal with a screenshot. Okay, yeah, everyone's ready. Thank you very much. Smile. Thank you very much. And as usual, I am passing my imaginary microphone to Galyna Tabunshchyk, who is our speaker today. She is a professor at well, here it's called computer science department. In Ukraine, they call it software tools department, but it's computer science. And she's going to talk today about predictive modeling using a Python package, Scikit-learn. Thank you very much.
So thank you, Helen, for introducing me. I will share my screen now. Yes. And well, I'm very happy to see you all today. It's our fourth summary workshop, which just deals with the basics. As it was announced, it is friendly for beginners workshop for Python for data analytics. What we are going to do today? Today we will have small introduction for those who are first time here. Then we will look through data analysis process, and as you could see further, we could see what we have, what possibilities of Python and Scikit-learn we have to deal with each stage of our data analysis process. So before we start, let's pass a small quiz. For those who are first time here, there will be a few questionnaires within the lecture, with this workshop. You could go with this QR code or go to the menti.com and type this digit code. Then I still need to find, here is it. And now I will start. For those who are first time here, yes. Well, just like this chart very much within these workshops. It's always like equal distribution between participants. It's very nice to see. And to the second question, please answer if you have already participated in previous workshops. So I'm very happy to see that 60% already participated in previous workshops. So you already have some basic knowledge which we needed to do with today workshop. This is very good because, as I have told already, today is like a small summary of all we have passed to be ready for further personal improvement. Okay. Here is still no questions, but if you will decide, you will know where to ask. Yes. So the second thing which I want to, for those who are first time here, I want to remind you that each workshop has its personal Google Classroom. For this purpose, you should go to classroom.google.com and join into the classroom and put this code which give you access to the materials. As always, all the same. Today, you see it's the minimum tasks in comparison to other workshops. So here you can find my presentation. I will upload the final version for sure after we finish today. And then there are 3 tasks which you should solve. So as it was agreed, I will accept your submissions from all workshops till 2nd of August. And I know that some already submitted after my remarks or edit submissions. I will check them for sure, don't be afraid. I will check or write to you, and you could upload your tasks here. As you're probably all working or have other tasks, I suppose that you will mostly do it on your weekend. So that's why I put 2nd of August including, and then I will send all information for Helen, who will make certificates for you. And there are some chats already active. Yes, already answered. Yes, this is code. You could see, and you could get access to the materials. Also, as today is the final of from all workshops, I already hadn't put in our timetable that I should start with the development environment. So that's why I expect that you have already installed Anaconda Navigator or Charm Community, or you are ready to use online resources. That's why it's your choice what to choose. I ask you to upload to Google Classroom Python file. This makes me easier to check. Sometimes your imagination is great and I can't like check it looking through. I run your code, and this is makes our cooperation more comfortable for all. So also, as I already told, what we will use today. Today we will use for sure numpy. Today we will use for sure matplot, and today we will use for sure pandas. And this is, I suppose, should be your back knowledge for material what we are going to do today. Of course, if you are first time here, don't be afraid. In general, I try to find, as we already announced, that we are beginners friendly. The examples will be, I hoped that examples are done in very easy manner, so that you could follow them even if you hadn't participated in previous workshop and not so skillful. So that's why I just like want to know how skillful you feel you are. I will go to Mentimeter. Still no questions. So for those who are first time here, you see you should go to Menti.com and use code 299532 to get access to this our pie chart becomes more interesting. So it's good that most of you have Anaconda. It is a good free tool, which very comfortable for data science. Happy to see more people here. In the beginning, there were only 8, now 15. So I want to tell hello for those who only now joined us. So, and this is how I feel very comfortable. Oh, not goose, but not good. Sorry. Generally, I'm first time using this chart. So, I hadn't understand the question about Google Classroom. You can't. So we're going to practice more code you write, more skillful you are. So it's really good. Yes. Okay. The chart is done without me. It's easier. So thank you for the answers. And let's go to our presentation. So today we will learn 2 more module packages. We will go through possibilities of Scikit-learn and Seaborn. So to have just to show you how great variety of packages has already Python to help you to provide your analysis. And this is only a small part of its possibilities. So Scikit-learn, it's its package for machine learning, and it is built on numpy, scipy, and matplotlib. That's why our workshops was constructed one by one. Yes, so that first we go through matplotlib and numpy, then pandas, because we will also use data frames for our analysis, and this package also contains, so also is built based on these packages. So let's return to our data analysis process. The data analysis process, it's from the problem definition to solution, pass through 6 main stages: data extraction, data preparation, data exploration and visualization, predictive modeling, and model validation. And the final is deploying, but we are not looking for deploying because it is already for you to deploy your model to your practice. And we will go through each step one by one today to see how we should pass all this, how we could use Python for each state for our data analysis. So for problem definition, we don't need Python. Yes, for problem definition, it is very important from business task to transform business tasks to data analysis task, and its additional problem, how to extract data, how to generate this idea. And the main is like I like very much that when you trying to define the problem which you are trying to solve, you should answer 5 who. Yes, who, when, where, why. So when you will answer all these questions, then you could go to the next stage. So then you could see that you understand business goal and you understand which methods from data analysis you could apply to reach to give this additional value to your company. Yes, to provide to conduct this data analysis to receive your goal for improvement. So this is the main idea of problem definition. After you define the problem and you know what you need to analyze, the first stage is data extraction. Data extraction could for data you could use batch processing tools, open source tools, cloud-based tools, and also you could do full extraction and incremental extraction. In the end, you have data, but this data could be just raw, unstructured data. Of course, if you are very lucky and you conduct analysis yourself, you know what you should, what data you should to collect, then of course, in this case, you are lucky. You have in the end structured data which you could use for your analysis. Normally, when you are trying, when you are learning, you are download any open data which are now too much in the web. Yes, and then you generally has some unstructured data which you need to proceed with. How you could extract data? The first, so if you are working with open data, and the first you should use package for uniform resource locators, yes, which helps you, which perform get request and upload data, load data. This is the best. This is the best way that you first upload data to your computer and then use it with with pandas or numpy or pure Python possibilities for your data analysis. So this example, yes, you are not saving data. You just read the CSV file directly from your address and store it as a data framework and work with it. For those who are first time here, I just want to tell you that all examples normally I've checked before, and this means that you could easily copy paste it. So if you never work, so you could easily copy paste it. I hope that it will work now. Okay, so you see that we download our from, we have this link to the data or to the open data, and we use a method of pandas. Yes, so don't forget to use pandas or other packages. You should first install them and then import into your project. So what we have in this very small example, we import pandas and save it as an object. Yes, so don't forget that in Python, all variables are objects because all types are classes. So we have it as an object, and we read from text file with delimiters into data frame. So when we are working with the data frame, we could list only parts of our data frame. So for this, we are using, for example, heads and tails. So you could see that heads with argument 6 print 6 lines of our data frame. Yes, and tail return us 3 last rows from your data frame. So, and the data, you see, I don't have any stored files at my computer. It is downloaded directly from the web. Also want to remind you, because we will also need it, yes, this is non-type. So this is non-numeric object. Which is usually or incorrect or missing value. And to help us to work with data and not to stop it, we have this in such places where we have empty spaces or we have mistakes in calculations, we have this non-objects. The other possibility, as I already told, first step to save it, download it to your computer, and the second step is to read it into your data frame. Our Scikit-learn library. So this a lot of packages already for the tutorials for the help of learning these packages contains built-in databases, and Scikit-learn the same. It already contains datasets, packages, yes, which you could use for your purposes. They have small toy dataset and they have big dataset. Generally, we don't need big data for our tasks, so we could use these small toy datasets for our first steps in data analysis. You could see there is 1, 2, 3, 4, 5, 6, 7 toy datasets, and generally we will use today iris for classification of flowers, diabetes for construction regression models, and for your tasks in the classroom you will use wine dataset. So these 3 datasets you will use for practicing your skills. Each data set, if you want to practice with them further yourself, has a description in your in the Scikit-learn library. So to download them, first of all, you use method load and name of the dataset. Load Boston, load Iris, load diabetes, load digits, and this is one moment, and this is description of your dataset. Usually it's not for all datasets, but normally they are all dictionaries. Like data contains data, input data. Yes, target is labels for classifications, and target names it's names for your classes. Yes, and feature this is for Iris database, and feature name this is the names for your features. Description contains full description of the dataset, so you don't need to search also in the web if you're just like Mr. Don't have time. If you will print description, you will see the full structure and description of the data. So this is, for example, how you could extract data from dataset Iris. Let's go to the let's try how it works. So here is already we import 3 packages. First, from Scikit-learn, we import dataset. We import pandas and we import numpy. So you could see the difference. Okay, first we load Iris data set. What we have? We have a dictionary. You see, data, it's an array of your features. Yes. Target, it's an array of classes. Target names, it's the name for our classes. And we have features names. This is the name of our features. This is what is done here. And here is one of the possibilities. We further will go through another possibilities, how we could create a data frame from this data. For this, here it is like, maybe I should put it twice versa, this is more complicated. We are using a method from numpy, which combined our data with targets. Yes, you see, it gives the name species for it, and we have so we have all organized in a correct way. Yes, so we have now names of our features on its place, and we have the name of our classes, so it's quite comfortable. And also, as it is already And data frame, we could use, we could show only those information which we need for our data analysis. Generally, very often, when we create any our personal methods or our personal approach, we don't have some data, yes? So we need to check how it works. For this purpose, Scikit-learn has a very good possibility. It has a method which allows you to generate data for the task. So on this slide I put only 3. There are much more. Like this method, make classification, allows you to generate sample and which has as many informative features as you need, and you could put as many classes as you also need there. So it's generate a sample with the data and classes in some random way, yes, to which you could use for your further analysis. So if you want your data to be distributed according to Gaussian distribution, better use the method make blobs. Also possible to generate data for regression model. For regression, we have a method make regression. Here is it. So generally, you put here how many inputs and so how many inputs you have. You put a bias if you need it. Yes, you could put the level of noise, and then it will generate you a sample which you could use in the tasks where you want to build a regression model. Let's see quickly if it works. So here you see it's generated. There is some. So you can see why it's our class generated. Yes, in easy way. So I put that number of classes 2, class report classes. I put number of classes 4. So I have 4 classes from 0 to 3, and I generated a sample. Yes. So and then I could use this. Here you see from these 2 arrays, I could create a data frame, and then now in the end it looks like a data frame with your data and classes, yes, which you could use or in this way or in this way as a data frame for your further analysis. So you have already a sample of just a moment, also like number of features, yes, 10 features which you need for your analysis, for your experiments. Let's tell in this way. So just quickly systemizing. We was talking about data extraction. So for data extraction, we could extract data from anywhere in the web. We could use for this as package URL lib, or data or pandas packages, or numpy packages, or Python. So it depends. Also, a lot of packages contains built-in datasets. Both and Scikit-learn and Seaborn contains these datasets which you could use, and you could load them to make your analysis. All descriptions of these data sets are one of the features of the data set, so you could easily read about it. And if you don't want to use any standard data set for your sample, you could generate it yourself. I just put 3 examples. There are much more methods. So depending on the task which you want to do, you could generate sample for classification or for regression, for example. So it's a little different tasks. So you generate, normally you see continuous, so all these methods which I showed you created continuous variables. But also, if you need, you could generate discrete variables as well. Yeah, your scales of your variables could be or nominal or ordinal or interval. So for all, there exists possibilities for data analysis. So after you extract your data, any comfortable for your way, you go to the next step, data preparation. In the end of this stage, you should have this code book. This is very good practice for you if you are working with data analysis, because in some time you forget variable names, you forget about information about your respondent group, about variable location. So sometimes you think that, oh, I will remember it forever. Don't be sure, because like sometimes tasks reappeared within the sometimes, and when you open your data, you just like looking at them and think, oh God, what is there? So I never saw them before, this data. It was not me who made those analysis. So you should, after you finish this data preparation, you should always have this codebook. Yes, it's boring. Yes, it requires your time, but it is very important for reliable data analysis. What you are doing within this data preparation? Normally, you are doing 3 main steps: cleaning, normalization, and transformation. For example, dealing with missing values or scaling. Dealing with missing values, we already work with it with those who was attending our workshop on pandas. So pandas contains several possibilities to work with missing data. The easiest one, like clean all your missing values, use drop function, and this will delete all your missing values. If you don't want them to be deleted, you could fill them with some value. Other possibilities that you could predict missing values based on your models, so first you have a subsample where you have which nodes contains missing values. Then you build prediction function and use it to fill with the method fill with this function missing values. Let's look example. So we have information about Titanic passengers, yes, which we downloaded somewhere, and let's see how it will work in these two different possibilities. So first, I read our file. I print all unique values which contains column cabin, and if there are missing values, I fill it with this new value, and I want to print now new unique value from this column. So let's see what we will have. So here is the results. Yes, so we have information about our passengers, and we say that cabin contains, so as it is only part of the data frame, yes, it has 890 values, so that's why it's not reasonable to show all. You see that there's some information about cabin is missed, and when I'm printing unique values, you see, here is we could see all cabins, all unique cabins where was passengers, and you see also there was non objects, yes, incorrect variables. So after we fill with other value, you see, there is no non-objects. All missing values are filled with a new one. If I'm not so smart, I don't want to know about missing data, I just delete all missing values, and here you could see the result. You see, just simply all non-values are deleted. We could this, sorry, this is okay, it's long, so just like to say, okay, we will save it in other. So all values I just wanted to show you and that all missing values deleted. Here is it. Okay, will not fight with it as last time. So first we could and the third example, so sorry, because not all managed with it, just to show you. So if you want to fill it with some values, so more reasonable to use mean value for the column, like in this example. And here you see that third element was replaced with mean value. So what we have in this example, for those who are not with us, So we generate our data from dictionary. Yes, we have our dictionary. It will be our rows X with values, and one of the value, it is non-object from numpy. That's why we import numpy. And here is our sample, yes, which we could use. And if we want to fill our missing values with the min value or with any function, so generally you could write your personal function, yes, which could calculate, will be like a regression model or something, and then you could or like mean from some subsample. It depends on your task. There are a lot of possibilities dealing statistically with the missing values. So you could fill it with a method from pandas library package. So also you could not only delete, but you could also create. So sometimes you need to create variables. So Helen, are you dealing with questions or? Yes, they are not calculating, and they're like just missing. Normally, these rows are missing from analysis. So sometimes you need to create dummy variables. Dummy variables, it's a numerical variables which are used in regression analysis, for example. For example, if you want to distinguish between groups which take treatment and which not treatment, you could use these dummy variables. To create these dummy variables, we use method getDummies from pandas library, and as a result you see our data frame, yes, is transferred, you see, with the prefix A, and from column A and stop, and yes, from for column A and B you have this dummy variables. So okay, also we saw already in all three workshops there are numerous possibilities for basic statistics, and the final is, for me, it's like the most comfortable one, is for basic statistics from pandas, that we are using method describe, which show you description statistics as one table, and also method correlation, which show you Pearson correlation. Yes, it's linear correlation. We will look it further as well. It's linear correlation, which shows if there is linear correlation between variables, two variables. The next step for data preparation, it is normalizing data. So when you want to create a regression model, what could happen? So what means that you want to create a regression model? So yes, so you want to have this model. And then, yes, when you receive your coefficients with the help of this or that method, you have this something like equation. So what these wages tell us? These wages tell us if how each variable influence on our output. But this is incorrect if we are using raw data, because the scale of each variable could be different. Yes, this could be millions, and this could be something like 100. And that's why we can't tell that this coefficient is telling us anything. So to have possibility to estimate how really each variable influence on our output, it is a very good practice to normalize our data. And there are also several possibilities where we look only at two from them, is how we could normalize data. One of the possibilities it's maximum scaling. Yes, where you are using for each value in your sample. So you have a minimum value, have maximum value, and so you normalize it with this formula. So you always know that minimum will be 0 in your normalized data, and maximum will be 1 in your normalized data. The other possibility is to use a standard distribution. So you make a normalization according to the normal distribution and use for it your mean value and standard deviation. Yes, to normalize your data in your sample. In the Scikit-learn library, there are in the package preprocessing, you have different methods to normalize your data according to min-max method. You use this min-max scale method. Yes, where you use which you could use for normalizing your data. Also, you could use, you can see methods such as fit, which helps to compute minimum and maximum, yes, for your values, transform, help to transform data, get parameters for estimators, and apply scale. So this is a very useful possibility in Scikit-learn library for using this for using this normal distribution approach. You use a standard scalar method, which you apply to your sample. So let's go for examples. So here we are using our min-maximum scalar, and let's run our example. You see our maximum values transformed into 1 and our minimum values transform into 0. If we will use normal distribution scalar. It will be other picture. You see? So all our data is normalized according to the normal distribution. Yes. Here we are not working with pandas. We are working with the numpy array. Yes. So we generate numpy array. Yes. And we transform it and normalize it. So this is what we have after normalization of our data. So now I want to invite you to Mentimeter to have some rest a little from all this data different. So I'm very happy that 3%, 4%, 5% still survived after 1 hour of material. Happy to see the 6th one. Okay, you're already great, you survived. So let's go. Perfect. Perfect answer. You are great. And let's go further. So how to create dummy variables. Okay. The third is a method from pandas, which allows to fill missing values. But already 10 people here. So Christina is our winner for this small quiz. I hope you are awake, and we could go further for the next step. It's data exploration and visualization. At this step, we are doing summarizing data, grouping data, exploration of relationship such as correlation coefficients, and trying to make identification for patterns and trends. Construction some regression models, maybe. So the easiest way is to do pivot tables, yes, which helps you to transform your data. And this pivot is also a method from pandas. And the example is workable. We worked with this previous workshop. I just put it here to remind you that this exists. The second, very important, it is correlation matrix. And in this example, it is done with the help of, so we are, let's go through it. And to see. So what we have here, we from a Scikit-learn import dataset, we will use numpy and pandas, and we will also use matplotlib for visualization. So we are using a data from dataset iris. We transform it into data frame, yes, and create species, yes, where we're using, so where we're using where from numpy library to set our conditions. To calculate correlation for our flowers, we are using method correlate, and with the help of stat models AP create and matplotlib create our graph. Let's see. So this is our statistics for our, here is it, yes, descriptive statistics for our flowers, and then for each for each one we are constructing a histogram, and for this purpose we are using matplotlib. Just to remind you, yes, that it is possible with the help of matplotlib to print one graph or several graphs, and you could always save the result to use it for your reports. And the next step, we have our bar plot. What is very important here, you see, this is our minimum maximum values, this is our average values, and here we have values which are without range, so they are abnormal. This is very important for this purpose, this plot. Yes, when you could see how your variables are distributed. And here we see our correlation matrix, and here we could, because don't forget that we cancel this diagonal, so we're looking that these variables generally, yes, these two variables, we could tell that they have strong correlation. So we are telling that we have strong linear correlation when our Pearson coefficient is more than 0.75. So we could tell that here is a strong linear correlation. And what is a correlation? Correlation is, so you could just like tell that there is some relationship between these two variables. So, but we don't have models which helps you to make prediction. Before we switch to prediction, I just want to tell you shortly about Seaborn package. It is very nice. It is based on matplotlib, and it contains much more possibilities than matplotlib. So it has the same possibilities like his. This is bar plot, a box plot, yes. So and pair plot, yes. So when all variables, yes, pairwise relationships in the data set is visualized. This is a very nice package for my opinion. And they also, if you want to learn how to work with it, it's also nice to see that what I told you. It has also built-in data set which you could use for practicing. And with this Seaborn package, you could construct also linear regression graph. I'm very sorry. I will return in one. Wait, sorry.
While Galyna is away to fill in the pause, if you could unmute yourself and tell us what do you like about the series and what would you like to learn? Oh, Galyna is back.
Yes, sorry, I returned.
But my question is still relevant. Please message it, send a message in the chat or reach out directly. We are very interested in feedback. Thank you.
My screen is still visible?
Yes, it is. Linear regression. There is a typo.
Okay. Very nice. Sorry. Okay. So it is very nice, but you know, here is minus. So when we're talking about linear regression, the idea is that we want to find a model, yes, and we want to find our coefficients. And here we can see them. Yes, we see only nice graph, and this is the disadvantage that we can't use it for further. So like for visualization, very nice, for quick, nice, beautiful. But if we want to have our data for further analysis, we should continue with other tools. So predictive modeling. What does this mean? Predictive model. The main idea why we are conducting any data analysis is that we want to use the result of this analysis for further prediction. So each morning we are looking at our telephones to see weather prediction, yes, to understand should we take umbrellas or not, yes. So we are making prediction about the mood of our colleagues and a lot of other things. So in our everyday life, and now we are making prediction if the vaccine of COVID will be developed soon. So, but the result is so our output variable is depending on our input variables, and that's why there are 3 different tasks which could be solved. It is the classification model. Like, for example, if looking on a human or not, or on a thing or some, yes, according to its features, we put it in this box or to the other box, yes. So because of the size or the usage or anything, yes. So and this is classification model. So depending on the features of the object, we put it into this or that class. A regression model is when we have a model which help us with the usage of numeric data. So when we have numeric input and output, make function, and if we put the value of how many salt we put in our dish, yes, how salty, so the level of the satisfaction, like it will be, yes. So and this is our regression model, which we want to have as a result. And clustering models, usually it's very similar to the classification, but we are not using classes, we're using clusters. But the idea, so the main thing is that we're just using different methods. So like according to different features and the distribution to the mean value of these features, we put our object, yes, to this cluster or other cluster, yes. This is 3 main approaches which are used for predictive modeling. We will look today for 2 only. We will look for linear regression and with the usage of Scikit-learn. And the second, we will use classification, how to construct a classification model with neural networks. So just like very simple examples. And this knowledge you can use like for applying other methods, because nowadays there are numbers of different approaches for construction regressions, for finding regression coefficients, and or for classification your objects according to the features. So when you want to construct the model, the idea is that you already have this data, yes. You have your data, it is already extracted and prepared, so you already make some first analysis, cleaned already, and next step is to construct the model. The idea is that if you use old data and make your model, generally you will never know how correct your model is. Maybe your sample was not representative, or like in different condition to work other way. So normally to have possibility to check that your model in the end is correct, you separate, you divide, it is called common approach, you divide your sample into 2 sets. Training set, so this set which we'll use for construction model. So based on this set, you will receive your model. And test set, so you will give your test set as input for your model and check and validate if your model is correct. And even for this data which was not used for constructing the model, your model give correct results. So this is the idea of model validation. So you should first receive model and then check if it gives you correct results. For checking results, there are different IPs which you could use. We will use for our purposes for perceptron, we will use scoring parameters. Yes, for this purpose, we have package accuracy score, which show how is correct your data. Or also for regression models, there are existing metrics which are usually used for validating regression models, and they are R-squared metrics, root mean squared error, and mean absolute error. For this purpose, you have also metrics. You see, this is also in part from Scikit-learn, and mean squared error. It is it is squared true, and root mean squared error. It is squared false. You see, there is numerous of other metrics which helps you to validate your model, which you receive for your prediction purposes. So the first and easiest, it is just the easiest way. So but like when we looked at Pearson coefficient and saw that, oh, it's more than 0.75, this means that we have that probably we could build linear model and use it for prediction. And for this purpose, there exist two main methods. One method is least squares method, and the second one is likelihood method. So what is the idea of least square method? It is like easiest one. I will also try quickly. I hope I still have time to explain you. So the idea is that you have like scattered plot, yes. So you have distribution of your variables. Yes, so this is blue dots. And the idea is that we should construct our line and construct it in this way that this should be minimum. All these destinations to your line should be minimum. So you should minimize in the end this function. So this is the idea of least squares method, which helps you to construct this model. And in the end, you have these coefficients which you use for prediction. So then you could input other values of your input variables and see what will be your output. Now, let's see for the example. So what we have in this example, here we are using a diabetes database, and we have input variables and output variables, and we divide our variables into train set and test set. Yes, after it we are constructing a regression model based on our train sample, and after it we check validate our model with the test sample. The final step is validation. We have you see, so in the end we have what okay, I will return in for a moment. So we have our model, and we as input give there our input variable from the test sample and received prediction variables. Then we calculate mean squared error and put there our values from our test set and which we received based on our model. The same for R-squared coefficients, yes, and this is all with the help of matplotlib shown on the graph. Let's see. Okay, first of all, you see we have our coefficient for our model, yes, for our input variable. We have our mean squared error and we have our coefficient of determination. So generally, you see our model not really fit very good. Yes. As a result, so we could make the conclusion that this model is not fitting very good. There is these results. And the second example is usage of neural networks in Python. This is also a very comfortable possibility with Scikit-learn. So generally, if you have any object which features yes, you could use a neural network for your predictive modeling. As you could see, the steps just the same: importing dataset, cleaning the data, scaling the features, creating training and validation set, and measuring accuracy. The idea is that while you are training your neural network, you adjust wages of your neuron for which helps you, yes, like each feature helps to adjust wages of your neurons to receive the output. And MLP classifier is used for your perceptron, multi-layer perceptron. Yes, so this method allows you to train your multi-layer perceptron, and then you could So what means to train? You could adjust your wages in each neuron to receive your output. So this is what we're going to do to classify our uh, flowers. Let's go and see. So what we have here, so we will use pandas. We will use from Scikit-learn dataset. We will use the object which allows us to split our dataset into train and test datasets in a random way. And we will use a multi-layer perceptron classifier to create a model to classify our flowers. So first step is data extraction. We download our data. The second is our data preparation. Yes, we create our data frame. Yes, and then we use train test split to create our samples, test and train samples. And after it, we train our neuron, and we train our neurons. We train our neurons and create our model. And then we just test what we have, which result we have while using the first the data from our train set, and calculate how correct our predictions. So okay, so all steps, yes. So first we see our raw data, and then we have our iris data. Yeah, so we have printed only locked input data. Yes, this is our input data. Features of our, this is our features. And then this is our classes. And I would tell that 35% of that our train test size should be 35% from the data. And there is some mistake. Okay, we will see. This is the result of prediction. We could see maybe, and this is our score. So our test fit for 84, mostly 85%. It gives correct result. Here you could see that we could increase number of iteration, and just to show you result. So you see the result when we increase number of iterations. Our result is that the prediction is 100% correct in this case. And here you see, yes, this is the result which we received after for our values, and here is what was real values. It's the same 100% correct result. So this was the easiest, for my opinion, examples of these two data analysis process when you could quickly construct your prediction models. For if you need a model for regression, you are using linear regression, and if you are using if you need classification, the best solution for nowadays it's neural networks, which you could use, like multi-layer perceptron. It's like also the easiest example. So it just simply adjust more iteration you have. So it's just like remember each case. That's why more iteration you make, more data fixed, so it gives you higher scores for your prediction. So thank you for your attention today. The final quiz with 2 questions. So if someone still survived, please go to Menti.com and okay, I'm very happy that still 9 people are here. Thank you very much for being so attentive. And the final question, if you would want to continue with Python, what would be most interesting for you further? So, thank you very much for your time, for your interest, and I hope this workshops was useful for you. And now I want to tell you goodbye. The final question is, one moment, I will return sharing screen. One moment. Sorry, I forgot. Very important thing. Let's look at task 1. So this is the way today. It hadn't stopped on it. Pace was quite fast, but like first download toy dataset Wine from Scikit-learn and normalize any column you want. with two different ways. The task 2, wow, where is my task 2? The task 2 was to construct regression model. I will I will check why I forget. Maybe it hadn't saved. Okay, so the task 2 is to construct regression model, and task 3 is for task 1 for this toy dataset Vine. Use a multi-layer perceptron for classification. I will correct task 2 in a few minutes when we will finish. So now that's all. As I promised. Okay.
Thank you very much, Galyna. There has been a question on chat. Maybe you can answer it from Christina. How can you tell if you have overfeature model? Can you create too many iterations for the amount of data that you have so the model doesn't scale to a new data set?
Where is it?
It's in the chat, but because of the thank yous, you would have to scroll it a little bit up.
So when you are, so first, you should understand which type of model. So a lot of, I missed part of the question. That's why I would like to find it to see it myself. Then you will also answer this question or not. So generally, no, like, so any model, so you should understand any model has its boundaries. So, and more iteration you make, more your perceptron is teaching. So it's learning. And that's why, like, this is a multi-layer perceptron. It has like a very stupid, like, if to simply explain. So it's remember all cases. Generally, this is the idea of this multi-layer perceptron. So it's remember all cases, and that's why more iteration you make, more cases recorded. Of course, if you have less neurons or less iterations, this means that not all cases will be recorded, and that's why results will be will have bias. And the second question is that all models has its boundaries. This means that if your data set which you will use for forecast, like for example, I'm in Ukraine, Helen is in London, yes, and if I will look, so when I am making forecast for the weather, if it will be rain today, I suppose there are different prerequisites for Ukraine, and even for Ukraine for different parts. Like when I go into Carpathian, their weather change 3 times a day, so I can't look in the window and tell, oh, if there will be rain or not. It's completely unpredictable. So there are a lot of other, you should use other features, not clouds on the sky. For a region where I'm living, generally clouds on the sky will be a quite good feature to predict if there will be rain. That's why, like, don't forget, so if you will take your data, input data from not from your boundaries, like that's why your model will not fit. I hope I answered your question.
Thank you very much. Oh, Christina said yes, thank you. I believe you did answer the question. Perfect. Thank you all very much. And please stay in touch with us. I have posted all of the links to social media. Please do reach out to us. If you have questions for this Python course, please ask them either on Google Classroom or on Slack. If I can't answer it, I will put you in touch with Galyna. Thank you all for spending your time with us. Hope you enjoyed it. And please share your feedback and have a nice evening.
So, bye.
Take
Thank
care.
you for being with us.
Bye.